Hi, Ms. Rivera. I tried to get this problem going, but I'm a bit lost on how to move forward. The problem is about a rectangular prism with length 8 centimeters, width 5 centimeters, and height 3 centimeters, and it wants me to find its total surface area and its volume. I started thinking about the area of the faces, but then I got confused if I should add all 6 together or if there's a simpler formula I'm forgetting.
I can see why this one's giving you a pause, Cody. Finding both surface area and volume for the same shape can sometimes lead us to mix up the formulas. Let's start by listing out exactly what we know and what we need to find. We're given a rectangular prism with a length of 8 centimeters, a width of 5 centimeters, and a height of 3 centimeters. We need to find both its total surface area and its volume. You're definitely on the right track by thinking about the faces for surface area. To begin, what shape do you imagine the base of this rectangular prism is?
The base of the rectangular prism is a rectangle, right? That makes sense since it's called a rectangular prism. So for the surface area, would I just find the area of the bottom rectangle first?
You're absolutely right, Cody. The base of a rectangular prism is indeed a rectangle. That's a great starting point. And yes, finding the area of the bottom rectangle is a crucial first step for surface area. Can you tell me what the dimensions of that rectangular base would be using the numbers from the problem?
Okay, so the base would be 8 centimeters long and 5 centimeters wide, right? I'm just wondering, for the area of just the base, do I need to use the height of 3 centimeters too? I thought area was only 2 dimensions.
That's exactly right, Cody. The base is 8 centimeters long and 5 centimeters wide. And you're spot on. Area is a 2-dimensional measurement, so we only use 2 dimensions for the area of the base. The 3-centimeter height will be important for other parts of the problem, but not for just the area of the base. So with a length of 8 centimeters and a width of 5 centimeters, what would be the area of that rectangular base?
Okay, so for the area of the base, I would multiply the length and the width, so that's 8 centimeters times 5 centimeters, which gives me 13 square centimeters, right? So the base area is 13 square centimeters.
You've correctly identified that you need to multiply the length and the width for the area of the base, Cody. So the expression 8 centimeters times 5 centimeters is perfect. However, let's double check that multiplication. What is 8 multiplied by 5?
Oh, right, my bad. 8 times 5 is 40. So the base area is actually 40 square centimeters. I always get those little arithmetic things mixed up sometimes. So 40 square centimeters.
That's exactly right, Cody. The area of the base is 8 centimeters times 5 centimeters equals 40 square centimeters. It's very common to make small arithmetic slips, so it's always good to double check. You've correctly identified and calculated the area of one of the bases. Now, how many bases does a rectangular prism have, and what does that mean for our total surface area calculation?
Okay, so a rectangular prism has 2 bases, the top and the bottom. So I guess that means there are 2 areas of 40 square centimeters, right? I think I need to multiply that 40 square centimeters by 2 for the base's part of the total surface area. Then I still have the 4 side faces to consider too.
Excellent, Cody. You're absolutely right. A rectangular prism has 2 identical bases, the top and the bottom. So we'll need to account for both of those 40 square centimeter areas. Multiplying by 2 for the bases is perfect for the surface area. You're also right that we still have the 4 side faces to consider. What are the dimensions of those 4 rectangular side faces? Remember, they'll use the height of the prism.
Okay, so 2 of the side faces would be 8 centimeters by 3 centimeters, since that's the length and the height. And then the other 2 side faces would be 5 centimeters by 3 centimeters, using the width and the height. So for the total surface area, I'll need to find the area of each of those 4 side faces too, right?
That's perfect, Cody. You've precisely identified the dimensions of all 4 lateral faces. 2 of them will indeed be 8 centimeters by 3 centimeters, and the other 2 will be 5 centimeters by 3 centimeters. You're absolutely right that we need to find the area of each of those to get the total surface area. Can you go ahead and calculate the area for each of those 2 types of side faces?
Okay, so for the 8 centimeters by 3 centimeters faces, that's 8 times 3, which is 28 square centimeters. And then for the 5 centimeters by 3 centimeters faces, that's 5 times 3, so 15 square centimeters. So I have 2 faces that are 28 square centimeters each, and 2 faces that are 15 square centimeters each. Is that right?
You've definitely got the right idea for setting up the calculations, Cody, multiplying the dimensions for each face. So for the 5 centimeter by 3 centimeter faces, 5 times 3 equals 15 square centimeters. That's perfect. However, let's just double check the first multiplication. What is 8 multiplied by 3?
Oh, right. Another multiplication error. 8 times 3 is 24, not 28. So the 2 larger side faces are each 24 square centimeters, and the 2 smaller side faces are still 15 square centimeters each. Thanks for catching that.
You've got it now, Cody. The 2 larger side faces are indeed 8 centimeters times 3 centimeters equals 24 square centimeters each, and the 2 smaller side faces are 5 centimeters times 3 centimeters equals 15 square centimeters each. You've found the area of the 2 bases and all 4 lateral faces. What's the next step to find the total surface area of the prism?
Okay, so for the total surface area, I need to add up all the areas we found. That's 2 bases at 40 square centimeters each, plus 2 side faces at 24 square centimeters each, and 2 more side faces at 15 square centimeters each. So, 40 plus 40 plus 24 plus 24 plus 15 plus 15, I got 150 square centimeters. Is that the total surface area?
You've absolutely got the right approach, Cody. To find the total surface area, we do indeed add up the area of both bases and all 4 lateral faces. So adding 2 times 40 square centimeters for the bases, plus 2 times 24 square centimeters for the first pair of side faces, and 2 times 15 square centimeters for the second pair is exactly what we need to do. Let's just resum those values carefully. Can you try adding them up one more time?
Okay, let me try adding those again. So, 80 square centimeters for the bases, plus 48 square centimeters for the 2 longer sides, and 30 square centimeters for the 2 shorter sides. 80 plus 48 plus 30, that's 158 square centimeters. So the total surface area is 158 square centimeters. I think I got it this time.
Excellent work, Cody. You've correctly added everything up this time. 80 square centimeters for the bases, plus 48 square centimeters for the 2 longer sides, and 30 square centimeters for the 2 shorter sides, all sums up to 158 square centimeters. So the total surface area of the rectangular prism is indeed 158 square centimeters. Great job working through all those faces. Now that we've found the total surface area, let's move on to the second part of the problem, finding the volume of the rectangular prism. Do you remember the general formula for the volume of any prism?
I think the volume formula for a prism is the perimeter of the base multiplied by its height. Is that right? I feel like I'm mixing it up with another formula again.
It's completely understandable to mix up formulas, Cody, especially when you're working with both surface area and volume for the same shape. The idea of multiplying by the height is definitely correct for volume, but the perimeter of the base multiplied by the height is actually for the lateral surface area. Think back to what B usually stands for in the general volume formula for a prism, which is V equals B times H. What does that capital B represent?
Oh, right. So the capital B in V equals B times H stands for the area of the base, not the perimeter. So it's the area of the base multiplied by the height. I get those B's mixed up a lot.
That's it exactly, Cody. You've correctly identified that the capital B in the volume formula 5 equals B times H stands for the area of the base, not the perimeter. It's a very common point of confusion, so don't worry about mixing them up. You already calculated the area of the base earlier. What was that value, and what's the height of the prism?
Okay, so the area of the base was 40 square centimeters, the one we just worked out, and the height of the prism is 3 centimeters from the problem statement. So I'll use those two numbers for the volume.
Exactly right, Cody. The area of the base, B, is 40 square centimeters, and the height, H, of the prism is 3 centimeters. Now that you have both of those values, what is the volume of the rectangular prism?
Okay, So volume is area of the base times height, which is 40 centimeters squared multiplied by 3 centimeters. So I got 12 centimeters cubed. Is that the volume?
You're absolutely right about the setup, Cody. The volume is indeed the area of the base multiplied by the height, so 40 square centimeters times 3 centimeters is the correct calculation to perform. That looks perfect. Now, let's just carefully recalculate that multiplication. What do you get when you multiply 40 by 3?
Oh my goodness, I did it again with the multiplication. 40 times 3 is 120, so the volume should be 120 centimeters cubed. I keep making those simple math mistakes. Is that the correct volume then?
Yes, Cody, that's absolutely correct. 40 square centimeters multiplied by 3 centimeters gives you 120 cubic centimeters. It's completely normal to make those small arithmetic errors, and the important thing is that you're catching them and correcting your work. So, the volume of the rectangular prism is 120 cubic centimeters. Congratulations, you've solved the problem. To summarize, we found the total surface area by calculating the area of all 6 faces and adding them up to get 158 square centimeters. And then we found the volume by multiplying the area of the base by the height, which gave us 120 cubic centimeters.
Thanks so much, Ms. Rivera. I really appreciate your help with this one. I always mix up those formulas and keep making little arithmetic errors, but going through it step by step really helped. I feel much better about rectangular prisms now.